Week 12, Part 2. Let's do some examples using Snell's law. So if we imagine that we've got an interface between air and glass, so this is some nice polished glass surface, and a beam of light is directed toward the surface. This is the normal. Let's have our beam of light directed toward the surface at an angle of 35 degrees. So that we could call phi1. That's the incidence angle. Remember, we always define it with respect to the normal. And the question is, what angle is the beam going when it's inside the glass? What angle does it come out in here? Of course, it bends, and from the experiments in class and in lab, you know that it bends toward the normal. So we expect it to come out something like this with an angle that's a little bit smaller than 35 degrees. Snell's law allows us to calculate this. Snell's law, if you recall, is n1 sine phi1 equals n2 sine phi2. And all you have to do is pick the two materials here. We'll let air be on one side and glass be on the other. We have to be told what the numbers are. For air, we will normally just regard it as an index of refraction of exactly 1. Glass can be various things, but most typically it's about 1.5, and that's what we'll use for this example. So now we've got everything but one of the unknowns in this equation. So n1 for air, that's 1.0. Phi1 is 35 degrees. N2 is 1.5. And phi2 is our unknown. That's the angle we're trying to calculate inside the glass. You can do the math and rearrange this. I'll let you figure all that out. It's the arc sine of 1.0 times the sine of 35 divided by 1.5. And that comes out to be 22.5 degrees. So that's our answer. Now, you can do various other problems very similar to this. You could have the ray coming from below, and it really doesn't change anything. In fact, you can do the whole thing just like this. You would have phi2 in that case and need to solve for phi1, or you could just do it the same way, still solve for phi2, but swap the ends around. Lots of different ways of doing problems like this.